Hmm. Interesting. Oh, hello again. Welcome back to the Rockin pop-up. My name is Marisa, and I'm the Public Programs Manager at the Santa Cruz Museum of Natural History. I've just been using my favorite tool, a hand lens, to check out this rock that I got here. And that's what's on the menu today with the Geology Gents, Gavin and Graham. We're talking tools of the trade. This program is for anyone interested in rocks, and we want to hear from you. So if you are out there, tell me in the comments, get to type in. And my question for you to get us going is, what is your favorite type of rock or mineral? So if you have a favorite rock or mineral, write it in the comments. We want to know. And without further ado, I am going to bring in the Geology Gents. On the count of three. 1, 2, 3. Here they are. Hi guys. Welcome.
Hey Marisa.
Thanks.
So good to see you again. I'm really excited to talk rocks with you all again. And you guys look to be in a different place today.
That's right. We're in sunny Santa Cruz at, spoiler alert, Graham's favorite outcrop. We'll get to that in a second.
Oh yeah. That sounds familiar from last week. And before we get into that, we also in addition to a presentation that the two of you have for us on the Geologist Toolkit, we also treat this as a Rockin pop-up, as a place for people to ask their questions and submit their finds. And we're very excited to have had a submission. And so after your presentation, we will share that submission with you guys and see if you can help this person determine what rock she found. And also for all of you out there joining us, if you have a rock that you would like to show Gavin and Graham, we have a link in the description of this video, and you can go to that link and you can drop pictures there, because I don't think you can drop them in the comments here. But you can also write questions throughout the whole program in the comments here. So that's what I gotta say. Oh, it looks like we've got some favorite rocks coming in. Ooh, this is juicy. Before we do that, do you guys have favorite rocks? Graham, do you have a favorite rock?
Ooh, oh my gosh, put me on the spot here.
Yeah.
So my favorite rock is, we don't see much of this around Santa Cruz, but I used to see it all over the place in Maine, where I first learned geology. And that is the rock that is called gneiss. It's a gneiss rock, but it's also spelled G-N-E-I-S-S, and it is a rock that forms deep underground and is squeezed and heated really hot, and it ends up sort of getting these dark and light stripes in it. They sort of take on this zebra-like appearance to them that I think is super cool. You
always gotta love rocks that have good pun potential too.
Exactly.
Great. Gavin, what's your favorite rock? Or mineral?
Really good question. Well, mineral is an easy one. My favorite mineral is fluorite, because I did my undergrad work on it, and it's really cool. It's often associated with hydrothermal events. So fluorite definitely is very beautiful. And then favorite rock is always a tough one. The first thing that popped into my mind are the amazing granites of Yosemite. So I'll have to say that. Anybody who's seen them gotta remember them. So
I'm sure a lot of people can relate to that one. Our other answers that we have so far are mudstone.
Ooh, good one.
Serpentine and aquamarine. And mine is marble. So, okay. Without further ado, take it away, guys.
Awesome. Thanks, Marisa. I'm going to go ahead and share my screen here. And so, as we said, today we'll be talking about the Geologist Toolkit. And so, before we jump into it, let's just define what we mean by the Geologist Toolkit. So, throughout the talk, you'll see these two symbols, and these two symbols identify the two sort of aspects of the Geologist Toolkit. And so the first one, signified by these hammers here, are the physical tools that geologists will actually take with us out to the field. Think rock hammers, things like that. And then the second aspect of the Geologist Toolkit are the things that geologists think about and reference in their minds when they look at outcrops. And so that I'll signify by this magnifying glass.
Love this, Gavin. So what we're talking about here, this is the bronze and the brains of the geologist. And so for each tool that we'll show, we'll mark it with one of these so that we can say like, oh, this is a tool in your noggin, and this is a tool that you can hold in your hand.
That's right. That's right. And so Graham, you mentioned this last week, and you mentioned your favorite outcrop, the Swift Street outcrop along Westcliff. And so I thought, what better way to bring to the people the Geologist Toolkit than to go to your favorite outcrop and just describe how we would both take this outcrop in and learn about it. What do you say?
Oh, be still my heart, Gavin. You're spoiling me rotten. Let's do it. Let's dive into the Swift Street outcrop.
All right.
So what we're doing here, so this is, kind of like what we might do working on an outcrop as a geologist. Is the first thing we do is we approach the outcrop and we look at it from a distance, and already we're starting to take in information about it and trying to understand what's going on here. So, so looking over at this, we'll actually, Marisa, if you'd help us talk to our audience, we'd love to hear from our audience some of the things they first see in this outcrop. Things that are, related to the rocks. So they can be colors, shapes, patterns, something about the environment, something to just help put us into context of where this rock is and what the properties of it and locating it on Earth.
Yeah, maybe like the setting, something like that. Any patterns? Sound good?
Okay, yeah, so you all heard them. If you have something that you notice, you can drop it in the comments.
Awesome. Okay, Graham. So you mentioned maybe the first thing you do when you walk up to an outcrop, and that is you look at it as at a distance. And so looking at an outcrop for the first time, we often want to just take in the large scale features. What jumps out at you about an outcrop? This might be bedding. If it's a sedimentary outcrop, it might have layers. Those layers we call them bedding. And so oftentimes when we look at outcrops from a distance, we'll do what I like to call geologic karate. And so here's a picture of Graham and I looking at an outcrop off in the distance. And you can see we're doing some karate here. We're talking to each other about what layers we see, and we're really getting into it, trying to find those massive features that we both see in the rocks.
That's right. So not every geologist tool is something really high tech. Sometimes we're just holding our hands and peering over them and tilting them to see if there are just sort of these general, broad trends in any sort of rocky outcrop.
That's right. And so Graham, you mentioned the low tech tools, but we also use some high tech tools, right? When we're at an outcrop, we want to know exactly where we are in space. So we might use a GPS to get our coordinates. And as soon as we get all that information down, we figure out what we can see at an outcrop, we sketch it down in our notebooks. And so this is me here looking at the outcrop me and Graham, or standing in front of the outcrop me and Graham were looking at, and I got my face in my notebook. I'm taking down all of these notes.
And I will say that, and I think we've had this conversation before, Gavin, and I think we both agree that of any tool you can bring as a geologist, or really as any scientist or just a curious person, you can't beat a notebook, something where you can take down and keep track of the observations you see, sketch them out, annotate them, make little notes, and keep track of everything you're seeing and processing in your mind. There's no better tool than having a good notebook that you take with you on all of your adventures to keep track of that. I certainly have gotten a lot of use out of and continue to cherish all my field notes.
I agree with that wholeheartedly. But I don't like to be away from the rocks for too long. So the next thing I'm doing is I'm walking
toward. Had some observations jotted down.
Oh, fantastic!
In our own digital field notebook that we have going on right now. So some people did have some observations that they'd like to share with you, including that it looked like there might be a layer of shells or pebbles, and it looked like there's capped with plants, dark on top and light below. So good observations to jot down.
Great. Totally. Maybe some contacts there between dark and light. Absolutely.
And those observations of those pebbles and shells below, I'm so glad that someone caught track of that. These are some very interesting parts of this formation here that we're not going to get into too much detail today. We've been talking about having a whole dedicated episode one of these times about those lumpy and bumpy formations down at the bottom of that view. And we'll just ask our viewers to stay tuned for an upcoming episode where we'll focus real closely on those. But for now, Gavin, let's get a little bit closer to this outcrop.
Love it. Okay. We're going to walk towards it now. And so when I'm approaching an outcrop, now I'm looking at sort of the medium scale stuff. A lot of new things come into view here. So first of all, here's the top portion of that outcrop. Here's the bottom portion of that outcrop. So you can see now that we have sort of the more soily layers on top. There's sandy layers. There may be some sedimentary features you can see in here. We like to call those cross beds. And then below,
cross beds because they're kind of they're at an angle, right?
That's right. And so that can tell us something about the environment. And so we'll get into that a little bit. And then sort of near the bottom, you start to see these more friable, sort of breakable layers. And something really cool that comes into view is that we have sort of a back and forth of those layering between these white layers that are more solid and these more crunchy sort of layers. And so something is going on here. These back and forths and these contacts above are evidence that our environment is changing. So we can get a lot out of the sedimentary layers we're looking at. And this might make people remind people about what we talked about last week, right? We have the Santa Cruz mudstone below, and you can tell that by the grain size and sorting. And you have the more sandy, sort of younger layers on top. So that's a change in the sedimentary environment that we see just from coming up to the outcrop.
That's right. And like we talked about last week, when you go from really fine sediments, those tend to be falling out far out at sea, and where things get a little bit sandier, you're closer to the beach, where you've got more energy coming in from those waves. And so I love this, how you can see these layers here, you can see these changes, and it's almost like you can feel the water rising and falling around you as you go through geologic time. Oh, that's right. Poetry to it, Gavin.
I love it. So we were talking a lot about sedimentary layers, especially in this outcrop. And so, Graham, what is one tool that geologists use to get maybe some more quantitative information out of those layers?
That's a great question. And so, right, we are awash in all of these wonderful ideas about like the rock types and these things changing, but it can be really helpful for us when we interpret an area or when we want to compare one area to another is to start bringing numbers into the mix. Numbers are a great way to keep track of and measure and, identify things or define things in a way other than just words. And so a really common measurement we make out in the field is strike and dip. And you're like, okay, Graham, yeah, those are just words. And you're right, they're words. But what we use them to describe measurements of a plane. And when I say a plane, I mean some flat layer in space. And we use those to say, how much is it tilted and in what directions are it tilted? And so to measure those values or to measure strikes and dips, we use a geologic compass. One of the most famous companies that makes them is Brunton. And so usually we geologists, we get a little bit lazy with our words and we'll just call them Brunton compasses, even though they're a geologic compass. And so these are really cool, precise instruments that we can use to take out into the field, and we can measure all sorts of great things about the shapes and slopes of the rocks we study out there.
Sweet. Okay, Graham. And so
this has been great. I feel like things just keep getting better and better as we get closer to the rock. Do you think we could have things get even better than this? Could it be even more wonderful than what we're seeing now?
Graham, it can be. And I have to say, the sedimentologist in me is just getting more and more excited as we go to the next part. And that is, we're putting our nose to these rocks. We're getting up close and personal, and we're seeing the minute details in these rocks. And so here are 3 pictures, one of the top of that outcrop that I showed you, the more soily layers, one of the middle, here, and then one of that muddy breakable stuff below. And so what you can see when you look really closely is that we can almost make out the grains, the specific grains that are making up this whole wall of rock here. And so on top, these grains are really sandy, they're larger. This makes you think of a beach deposit, or makes me think of a beach deposit. As you go towards the middle of that outcrop, you see these like really poorly sorted grains in here. And so
those big chunks mixed in with smaller pieces, right? It's not like we're just at a beach anymore. Now all of a sudden we've got big chunks of rock tumbling around with us, right?
Totally. And so you had to have had a really harsh, energetic environment. Think of big waves or storms, or even sort of mass flows like rock avalanches below the water and things like that. That's how you get these really interesting sort of unsorted outcrops. And then when you go below that into the Santa Cruz mudstone, you almost can't even make out the grains anymore. They're so small. It's literally a mud that's solidified. And so that's how we know these are really deep water deposits. And so, Graham, if say I looked at an igneous rock, what else may I be able to tell about the specific grains inside that rock?
Oh, that's great. So as a refresher from last week, igneous rocks, which we don't see too much of around here in Santa Cruz, igneous rocks form from lava or from magma. So you've got hot molten rock and it cools down and hardens. And when it hardens, you actually get crystals of the minerals that make it up forming. And so we can look at those individual mineral crystals and start to identify just what sorts of minerals are in here. And those are like the key tools. Those are the key things we look at to actually be able to identify any sort of igneous or metamorphic rock. And so as Marisa was showing us at the very beginning, when she was using her favorite tool, the hand lens, that's a really, that's a crucial tool to bring into the field as well. Often we can get a good idea of what's going on just by using our eyes. But if we really want to get into the nitty gritty, the minutia, if you will, of the geologic history, we've got to use a lens to get up close and see what's going on there at a scale smaller than our eyes can see.
That's right.
That's a good segue just really quickly to a question that we had earlier, which was just about the difference between a mineral and a rock. So it looks like you're saying that rocks are made up of minerals.
That's right. And I will also say, this is going to be almost the exact thing we talk about in next week's episode too. So yes, minerals are sort of the building blocks, what make up rocks. But if you're really curious, tune in next week and we'll get really into the details.
Turns out minerals are more than just something you take with your vitamins.
That's right. Okay, Graham. So we've let people into the Geology Gents secrets. When people bring rocks to us to identify, this is what we're looking at. You'll see us. We're gonna start looking at them really closely, and we're gonna take our hand lens and we're gonna look to identify the mineral type and the rock type.
Absolutely.
But Graham, sometimes visiting an outcrop is more than just leisure, especially for us who do this for a living. So what's the point of going into the field sometimes for us?
Well, sometimes, like you said, we go out to bring ourselves to the outcrop, but sometimes we also go to bring the outcrop home with us. And I mean, we collect samples to bring back and study within our lab settings, or get them to a place where we can inspect them or study them even more closely. So I see some familiar faces out here, including both of us, doing some field work and collecting samples. And so collecting samples looks like all sorts of things. Sometimes you're hitting rocks with a hammer. Sometimes you're digging deep into the ground. Sometimes you're pushing like a cylinder, a core into the ground so that you can pull out a block of sediment. It takes all sorts of forms. Gavin, do you recall what we were doing in this field work?
Fantastic question. Yes, I do. So this was in our first year of grad school. We went to these are the moraines of the Eastern Sierras. So they're glacial deposits. And so as you can see here, we're using all kinds of tools. And the one thing you'll also notice is that fieldwork is often best done with friends. And so in this first picture, you have me with my rock hammer. I'm just banging on these rocks, trying to break them up because we're going to try to take small enough pieces that we can fit into a sample bag. And we have Graham here for moral support, cheering me on while I break this. And then when I'm done, we have a nice pile of sediment and rock. Graham's here with another tool, his shovel. So sort of first order, but important geologic tools. And then the sort of last part is this scene here where we have Graham and I with our advisor here holding our sample bag. I'm taking some photos. That's always important. I got my trusty notebook to my side, and we're taking our samples home in our sample bag. So
That's right. Oh,
so
go
we
ahead.
have rocks to study, and we're sometimes just going to outcrops to take cool rocks. But Graham, what's one really important aspect of field geology and going to outcrops and taking rocks home?
Yeah, so one of the things is, so here it looks like Gavin and I are just, being a bunch of beasts banging on the ground and digging stuff up, but we're also being really careful. We're being careful to be collecting, being mindful of what we collect, but also how we collect, because we also, as we study an environment, we also want to be good stewards of that environment. So not only are we being careful that we're getting the right kind of sample, because we don't want to have to go back there and, fix a mistake in our sample collecting, but we're also being thoughtful of the land, how much of an impact we have on it, and being mindful of permission. And so certainly when we go to our local parks, I love to go and get my nose right up on the rocks and, investigate all sorts of outcrops, but it's also good to know that we can't take rocks from most of the parks we go to. And so it's always important to know we have permission to be there, and that if we take anything, that it's okay for us to be taking those things, so that everyone, ourselves, the critters, the plants can also, enjoy and keep having access to those rocks as well.
Awesome. That's right. And so this is pretty much the fundamentals of the Geologist Toolkit. We hope that you have learned some things, have some things to take with you when you go and investigate rocks. And so, Graham, what are we going to talk about next week?
Oh my goodness, this is getting into the bread and butter of what we study. This is what rocks are made of. So, yep, as we already talked about, minerals are the building blocks of rocks. What are the building blocks of minerals, and how do we put all these things together to make the just wonderful array of rocks and minerals that we see on this fantastic earth? I'm excited for it.
Me too. I hope everybody tunes in.
And so, Marisa, we heard that we have a treat today of a rock to identify.
Oh, there's more than just that. We actually got another submission while you were talking.
Yes.
So this is a big day. So Gavin, if you want to stop sharing your screen, I can pull up something to share with y'all. And there's still time. If you're watching, if you want a rock ID, you can drop it in the link that we've got here, but also we do this every week. So there's plenty of time. So take your time really thinking about what you're curious about. And it looks like we've already got deep interest in next week's topic. So
awesome.
You picked well. So what I'm going to do is pull up our first submission, which is from, let me see if I can pull up her original one. This is from Janelle. And here we go. So y'all see this?
Oh yeah, beautiful.
Yeah, so this is from Janelle. She said that it was found in central Pennsylvania in her backyard. So what are you guys noticing here?
Wow, that's a really, really cool rock.
We've got a couple.
Yeah, so the first thing that I noticed is this sort of like fibrous texture, right, Graham? This is what we call asbestiform.
Yes, so asbestiform is the same thing that the word asbestos comes from. And that's asbestos are these fine filamentous things that are often used in insulation. And there's all sorts of ways you can make it, but there are some minerals that make it naturally.
That's right. And so when it comes in this form, it's not the sort of dangerous asbestos that you think of in building materials. This is just a sort of it's actually a crystal habit in rocks. And so it's really, really sort of normal for certain minerals to be asbestiform. Graham, do you want to share which ones those are?
Certainly. Well, certainly the most, I would say the best known asbestiform mineral, and I have an inkling that this might be what we're looking at here, is the amphibole group. So we might talk about this a little bit more next week, but the way these minerals form is they form these long chains, and that helps them form these really long, and in this case, these fibrous strands of the mineral. And so Yeah, we see that this is asbestiform, this needle-like structure to it. We also see that there's a greenish color, and greens are often associated with the amphibole group. So I feel like we're honing in here, Gavin.
That's right. And so we had a few specific types of asbestiform. It's really hard to give it an exact mineral name all the time beyond the more general umbrella of asbestos, or not asbestos, of amphibole. But Graham, we had some things in mind. What were those again?
Yeah, so this could easily be something falling between the actinolite or tremolite groups of amphiboles. This is sort of a group where as you wiggle the amount of magnesium and iron in them, you go from actinolite at one end to tremolite on the other end. Those often have these, they can be kind of greenish like this. They can be all sorts of other colors too, but will often have these sort of long strand-like crystals to them.
Yeah, and
What
just to
else?
add one thing to that too is oftentimes the color when it comes to crystals, when it comes to crystalline minerals, the color is coming from the different types of metal elements that are in there. So it's probably the iron or the manganese. Oftentimes green like this can be copper too, because it oxidizes to green. Think Statue of Liberty.
That's great.
Cool.
Yeah.
Okay, it looks like we've probably come down to the bottom of this particular ID. So that's wonderful.
Yeah,
And I've got another one to share with you all. So this is an 8-sided yellow something is what it was pretty much described as. So what do you guys see here? It's 8-sided, they say.
Gavin, this will be a special treat for you, so I will let you take the stage for this whole ID.
Man, am I glad to see this. This is my favorite mineral. It's got to be fluorite. So fluorite, oftentimes when it's a perfect crystal, it wants to be an octahedron like this. And so whenever I see an 8-sided mineral like that, it could be all different types of colors, from purple, green to yellow. But I would be pretty positive that that's a fluorite crystal. And so you don't all the time see fluorite as the perfect octahedron, but when it has a lot of space to grow and can grow in the crystal shape that it wants to, because it wants to be this 8-sided crystal, it'll look like that. So that's a cool
one. That's just amazing. What kismet. That's great. I think that one was from Janet. So Janet, thanks so much for sharing that with us. So we got 2 IDs. That's great. So for everyone watching, we hope to get more. So if you have questions, I'm going to show you another option of something that you all can do actually. So you can send in a picture of a particular rock that you have, and like the better the picture, the better the ID probably. But also, I'm going to show you one of my pictures that I chose. So this is sort of more of like a phenomenon that we're seeing here. So it's an actual formation. So if you have pictures from your travels, you can also send those in. And thanks to Janelle for sharing where her rock was found, that it was from central Pennsylvania. That's always very useful, right, guys?
Yes, very.
Great. I guess since we've got this up, what do you guys see in here?
Graham.
Yeah, I'll go here. So up at the top of that, this is a really important phenomenon that geologists used to puzzle over tremendously, and were really critical for us understanding plate tectonics and the way that the lithosphere, or the plates of the Earth's crust, are moving around and interacting with one another. Those are fold. They're those kinks and those wiggles that you can see up above. That happens when you've got pressures that are squeezing the rock together, and they're causing it to basically close like an accordion might, or if you were to crumple a piece of paper into your hands. And so those folds show us that we're forming in a place where we have probably some geologic event that's bringing plates together, or at least bringing masses of the Earth together and causing them to be squeezed and compressed together. What else do you see, Gavin?
Graham, I have a question for you on this one. Do you think that could be migmatization? While it's folding, it's getting really hot.
I think it could be. Certainly the separation of the dark and light here, we always need to, be a little bit cautious because we can overinterpret when we do geology at 50 paces, right? We can, without being able to put our nose on the rock, we can't say 100%, but the flowy look of those things looks like this rock is getting hot enough, not only to separate out colors, different colored minerals like in a gneiss, but we're getting hot enough that this thing is almost melting. And it's getting kind of gooey, like undercooked brownies almost. And so they're a little bit mushy and are able to flow around one another.
That's right. Yeah. So I saw my favorite mineral. I would call this your favorite rock.
I would think so. This does look like a really high grade gneiss that got really hot and really squeezed. Marisa, can you tell us where you came across this?
So this is Kings Canyon. This one's actually in Sequoia National Forest, but along the Kings Canyon, that road that goes to Road's End, and then ends in Kings Canyon National Park. So this one was along the Sequoia National Forest section.
Excellent.
Yeah.
Gavin, I think you may need to go check this out sometime.
Yeah.
Oh gosh, it's just I was driving past it and I said, oh! And I found the nearest turnout and I ran for it. It was so beautiful. I've never seen anything like it. But okay, great. So I hope that we get lots more submissions for next week. If you're on Instagram, you can do hashtag Geology Gents with your submission, or you can drop them in our Facebook event or any of the posts that you see about this. We will see them, we will find them, and we will share them. And next week it's minerals, which is just really exciting. Do you guys have any parting words?
Just keep sending in rocks ID, and if you don't have any, by all means go out and get to know some outcrops.
Well said, Graham. I agree.
Right. And we did get a final thank you from Janelle that it's been a 20-year mystery for her. So wow.
We're so glad we could help. Thank you, Janelle, for letting us look at that rock. Yeah, and Janelle, if you got more, keep them coming. Okay. All right. Well, we're going to sign off now, everyone. But thanks for joining us, and we'll see you next week. Bye.